Welcome to the Capstone. Over 5 months, you have built foundational skills: advanced Kubernetes and GitOps, infrastructure as code at scale, service mesh and zero trust, reliability engineering with SLOs and chaos, and supply chain security. This month does not introduce a new technology stack. It asks you to integrate everything you have learned into a coherent developer experience. The premise is this: your CTO has read about internal developer platforms and wants the platform to feel like Heroku, but on your own infrastructure. A product engineer should be able to go from, "I want a new service," to "It is live in dev with telemetry, signed images, and SLOs" in under 30 minutes, without writing YAML by hand. We are going to build that experience using Backstage and Crossplane, with Argo CD and the tooling you set up in earlier months as the foundation. Here is how the 4 hours are structured. The first hour covers the platform as product mindset and the 3 core jobs any internal developer platform must handle. The second hour gets technical. We look at Backstage and Crossplane in detail. The third hour is the hands-on capstone where you build 4 deliverables. The fourth hour covers the operating model and closes with a retrospective on the entire senior track. The session goal is concrete and measurable. By the end, a product engineer who has never touched the platform should be able to create a new service from the Backstage portal and see it live in the dev environment, with telemetry, signed container images, and a base SLO configured in under 30 minutes, without help from anyone on the platform team. That is the bar. Everything we do today is in service of that number. The most important shift this month is not technical, it is conceptual. Infrastructure teams historically operated reactively. Tickets come in, tickets go out. The metric was tickets closed. The customer was whoever asked loudest. Platform teams operate like product teams. The customer is the product engineer. The metric is developer time to deploy. The output is not tickets closed, but capability delivered. The platform team builds self-service paths so that no product engineer ever needs to open a Jira ticket to get a service deployed. This means adopting product management practices. Your backlog is prioritized by developer impact, not volume of asks. Your OKRs are things like, any engineer can deploy a new service in under 30 minutes, measured by timing a fresh user with a stopwatch. You ship release notes so your consumers know what changed, what broke, and what was deprecated, exactly like an external product team would. And critically, you interview before you build. The worst golden path is the one nobody asked for. 3 questions to a product engineer before you invest 6 weeks in a new template will save you from building something nobody uses. Any internal developer platform must make 3 jobs self-service: provision, deploy, and observe. If any of these 3 require a ticket to the platform team, the platform has failed. Provision is everything that needs to exist before the first line of code runs. Namespace, RBAC, secrets, network policies, service account, resource quota, all provisioned via a crossplane claim. With Backstage, the product engineer fills in a form. The platform reconciles the infrastructure automatically. Deploy is everything from Git push to live service. The crossplane composition wires the Argo CD application and the Helm release automatically. The image is verified by Kubernetes before admission, that is the supply chain security from month 5, embedded directly into the deployment path. Observe is everything that makes the service visible. ServiceMonitor, a base Prometheus rule for the SLO, a Grafana dashboard, on-call routing in PagerDuty. The composition creates all of this from the SLO field in the claim. The product engineer names their availability target, and the platform wires the alert. Months 1 through 5 are all embedded here. IAC at scale is how Crossplane provisions. GitOps is how Argo deploys. Service mesh is the network policy layer. SLO engineering from month 4 is the observability scaffolding. Supply chain security from month 5 is the Kyverno gate on the image. This month is the orchestration layer on top. One of the hardest things about running a platform team is deciding what to support and what to decline. The golden path, paved road, and free-for-all spectrum is a useful framework for making that visible. A golden path is something the platform team owns end-to-end. The template scaffolds the repo, Crossplane provisions the infrastructure, Argo deploys, monitoring is configured. The product engineer never touches YAML. The platform team's on-call covers incidents on this path. A paved road is something the platform provides building blocks for: base Helm charts, Terraform modules, documented patterns, but the team must wire them together. If the service has an incident, the team owns the incident, not the platform team. Free-for-all is the term for teams that bring their own stack entirely. The platform provides nothing. This is not a supported state. It is documented because making the cost visible is what prevents it from becoming the default. When a team says they will manage their own stack, they are signing up for their own CI patterns, their own Docker file practices, their own security scanning, their own on-call. Most teams do not want that when they understand what it means. The 3 golden paths for this capstone are fast API service, background worker, and static frontend. For each one, you can see what is automated, repository, CI workflow, Dockerfile, Helm chart, open telemetry instrumentation, base SLO, RBAC, and what the corresponding anti-path is. Team API is a term from team topologies. It is a contract, a written statement of what the platform team owns, what it commits to, what it explicitly declines, and what SLOs it holds itself to. Writing this down matters for 2 reasons. First, it sets expectations with your customers. Product engineers know what to ask for and what to handle themselves. Second, it gives the platform team permission to say no. Without a written team API, every request feels urgent and in scope. With one, we do not manage custom ingress controllers is a policy, not a personal decision. What the platform owns: the golden path templates, crossplane compositions and providers, the Backstage portal and catalog, GitOps repository structure and Argo CD apps, monitoring scaffolding, and the certificate and identity layers from the mesh. What the platform commits to: under 30 minutes from service creation to live in dev, the Backstage portal available 99.9% of the time, secrets refreshed within 1 hour of rotation, and response to Sev1 issues on golden paths within 15 minutes. What the platform explicitly declines: managing custom application logic within templates, that is the service team's code, supporting off-path stacks. Teams that deviate get documentation, not on-call coverage. Provisioning production databases outside the approved module, that is operational risk the platform team will not absorb. Backstage is a developer portal built and open-sourced by Spotify. It has 3 core capabilities you will use in this capstone. The first is the software catalog, a searchable inventory of every service, library, API, and data pipeline in the organization. Each entity has a catalog info YAML file in its repository that describes the component, its owner, its on-call contact, its SLO, and its dependency graph. Backstage discovers these files through catalog locations registered in its configuration. The second is software templates, wizard-style forms that scaffold a new service, publish it to a repository, and register it in the catalog. This is the Backstage feature you will use most today. The third is TechDocs, a documentation system that renders Markdown docs from the service repository directly in the Backstage portal, versioned alongside the code. Architecturally, Backstage is a React frontend with a Node.js backend, Plugins extend both sides. The backend plugins connect Backstage to gitea for repository creation, to Crossplane for triggering application claims, and to Argo CD for showing deployment status. The data store is PostgreSQL, where every catalog entity, template execution, and TechDocs render is persisted. A Backstage software template contains 3 sections: metadata, parameters, and steps. The metadata section is standard Backstage catalog metadata. The name field is the identifier used in the catalog. The parameters section defines the form that appears in the Backstage portal. Each parameter has a title, a set of properties with JSON schema validation, and optional UI widgets. The owner picker widget pulls the list of valid owners from the Backstage catalog, giving the engineer a dropdown instead of a free text field. The name property enforces a regex, so only valid DNS label names are accepted. The steps section defines what happens after the form is submitted. The fetch template step downloads the skeleton, the starter repository structure, from a directory within the template. Nunjux templating replaces variables like the service name throughout all files in the skeleton. The publish gitea step pushes the rendered repository to your gitea instance. The catalog register step uses the catalog info YAML in the new repository to add the service to the Backstage catalog immediately. A 4th step, trigger Crossplane, creates the Crossplane application claim in the GitOps repository, which Argo CD picks up and reconciles. That is how the Backstage form maps all the way through to a running service. Crossplane extends Kubernetes with the ability to manage infrastructure outside the cluster, cloud resources. Helm releases Kubernetes objects in remote clusters, using the same reconciliation loop you already know from operators. There are 4 concepts to understand. The provider is a Kubernetes controller that connects Crossplane to an external system. The provider Kubernetes manages objects in a Kubernetes cluster. The provider Helm manages Helm releases. You configure each provider with credentials for the target system. The XRD, or Composite Resource Definition, defines a new API type in your cluster. Think of it like a CRD, but purpose-built for platform abstractions. You define the schema, the fields a consumer can set, the types and validation rules, the API group and version. When you apply an XRD, Kubernetes registers a new API. In the Capstone, that API is BISTEC DIO application. The composition is the implementation of the XRD. It is a recipe. When someone creates an application, create these managed resources. It wires namespace, Helm release, Argo CD application object, and ServiceMonitor together using patch and transform to copy fields from the claim into each child resource. The claim is what the product engineer actually creates. It is namespace scoped. The engineer creates it in their team's namespace. Crossplane reads the claim, finds the matching composition, and reconciles all the child resources. The status of the claim surfaces the health of every child resource. So the product engineer has one object to watch. The composition for the application abstraction references the XRD via the composite typeref field. The resources array lists every managed resource Crossplane will create when a claim is submitted. For the BISTEC Capstone, the composition creates 4 things. A namespace, using provider Kubernetes to create a Kubernetes namespace object in the cluster. A Helm release, using provider Helm to install the service's Helm chart with values patched from the claim's image, replicas, and env fields. An Argo CD application object, again via provider Kubernetes, pointing Argo at the GitOps repository path for this service. And a ServiceMonitor, which Prometheus discovers automatically to scrape the service's metrics endpoint. The patch and transform blocks are the glue. They copy the claim's ingress host field into the Helm values as ingress a host, copy the SLO field into a Prometheus rule annotation, and copy the image field into the Helm values as image.tag. The product engineer sets 4 fields in the claim. Crossplane propagates those values into a dozen places consistently. The sample claim for the shoes service shows what this looks like from the product engineer's perspective. 4 lines of YAML, with no understanding of namespaces, Helm charts, Argo CD configuration, or Prometheus required. That is the abstraction value. The hands-on challenge has 4 deliverables, 25 points each, 100 total. Passing is 75. Deliverable 1 is the Backstage portal with 3 software templates: Fastify service, background worker, and static frontend. Each template must scaffold a complete repository, Dockerfile, Helm chart, CI workflow, open telemetry instrumentation, containers, and auto-register the service in the Backstage catalog. Parameter validation must reject invalid service names and reserved names. Deliverable 2 is the crossplane application composition. The XRD must define a clean API with fields for image, replicas, env, SLO target, and ingress host. The composition must wire namespace, Helm release, Argo CD application, and ServiceMonitor from a single claim. Status from each child resource must surface in the claim's status conditions. Deliverable 3 is the golden path catalog, a markdown document describing the 3 supported paths, what each one automates, and what it does not. It must include an anti-paths table and lifecycle stages, showing how paths move from experimental to GA to deprecated. Deliverable 4 is the platform team operating model. Sprint cadence, PR review SLAs, on-call rotation, intake channel, prioritization framework, and release notes format, all concrete, with specific times and owners named. Anti-paths deserve careful attention because teams consistently underestimate how important they are. A credible internal developer platform says no on purpose. If your platform supports everything, it commits to nothing. Bring your own framework is one of the most common requests. Product teams want Flask, Django, or a Go framework instead of Fastify. The platform declines because per framework CI pipelines, Docker files, and security scanning rules multiply the maintenance burden with each addition. Bring your own database is the second. Teams want a custom PostgreSQL cluster, or MySQL, or MongoDB. The platform declines because unreviewed backup, patching, and failover policies introduce tail risk for the whole platform. The alternative is a platform-managed Postgres module that handles these concerns centrally. Custom ingress controllers conflict with Service Mesh NTLS and Kyverno admission policies. The platform's ingress is the contract with the mesh, and deviating from it breaks end-to-end RBAC and traffic policies. Server-side rendering and Next.js require a different scaling profile, security surface, and catching strategy than the static front-end path. The platform declines to support it on the standard path. It is a custom path the team must own. Custom secret access bypasses Vault and ESO, breaking the secret rotation SSLA and the Kyverno policies from month 5. The audit trail disappears. Notice the pattern. Every anti-path has a specific technical reason for the decline, not just a lack of time. That specificity is what makes the anti-path credible. How the platform team operates matters as much as what it builds. An excellent internal developer platform run by a dysfunctional team will degrade. A modest platform run by a tight operating model will improve over time. The cadence is 2-week sprints, with planning on Monday and a retro plus demo on the last Friday. The demo is public. Product engineers are invited to see what shipped. PR review SLAs are published. Pull requests that modify Golden Path templates get reviewed within 24 hours. Feature additions and new compositions get reviewed within 3 days. This is published so product engineers know what to expect when they contribute. On-call rotation is the part most platform teams skip. Golden Path alerts page the primary on-call engineer within 15 minutes. Primary rotates weekly and carries no feature work during on-call week. Secondary is offset by 3 days and reviews all incident action items. Sev1 escalation goes to the CTO and product engineering lead if there is no progress within 30 minutes. Intake is single channel. All requests go through platform requests on Slack. No direct messages, no verbal asks. A bot auto-creates a Jira ticket with an SLA timer. Prioritization uses RICE, reach times impact times confidence, divided by effort. Every feature request gets scored. The backlog is sorted by score, not by who asked loudest. Every golden path eventually ages out. Technology changes, usage patterns shift, better approaches emerge. The team that does not plan for deprecation will eventually face a choice between maintaining a path nobody uses and breaking the teams that still depend on it. The life cycle has 4 stages. Experimental is the starting state. A path is experimental when it has been deployed, but has not been validated at scale. Criteria to promote to gitea. Used by at least 2 teams for 30 days, documentation and tech docs complete, an on-call runbook written. GA is the fully supported state. The path has SLA coverage and appears in the Golden Path catalog as a first-class option. Deprecated means the path is still functional, but new services should not be created on it. A deprecation is triggered when usage has been dropping for 2 or more quarters, when a better path has replaced it, or when the maintenance cost has exceeded the value. During the deprecation window, which should be at least 3 months, a migration guide is published. The Backstage portal shows a warning banner on the template, and no new services are allowed on the path. Removed means the template is gone from Backstage, and the composition is deleted. Any services still on the deprecated path must have been migrated before this stage. The discipline here is publishing promotion and demotion criteria before you need to use them. Surprise deprecations destroy trust with your customers. Credible deprecations feel like a professional product release. To close the capstone and the entire senior track, take time to reflect on what 6 months of this work has actually built. Consider this. What surprised you most across 6 months? Not just technical surprises, but process surprises and how your mental model of what it means to be a senior engineer has changed. Think about which month was hardest and why. Was it the concept, the tooling, or the practice of applying it? Understanding where the learning cliff was helps you identify what would have helped someone else navigating the same path. Ask yourself what you would change in your team's current stack tomorrow. The senior track is most valuable when it produces one concrete action you take in the next sprint, not just a list of technologies you now know about. And consider this question. What is the worst golden path you have ever seen or built yourself? What makes a platform path fail? The answer is usually the same. The worst golden path is the one nobody uses. Building something your customers never asked for and measuring success by its existence rather than its adoption is the most common platform mistake. The 6 months built a specific arc. Advanced Kubernetes and GitOps in month 1. Infrastructure as code at scale in month 2. Service mesh and zero trust in month 3. SLO engineering and chaos testing in month 4. Supply chain security in month 5. And now, in month 6, all of it integrated into a developer platform. That is the arc of a senior DevOps engineer, from individual system reliability to platform capability. The scoring bands reward abstraction value, not just working code. An exceptional score of 90 to 100 means a fresh engineer goes from 0 to live in dev in 20 minutes. and the team API would survive a CTO asking what exactly the platform commits to. A proficient score of 75 to 89 means all 4 deliverables are solid with minor gaps, tech docs missing, one anti-path slightly weak, or the deprecation lifecycle criteria a bit generic. This is the passing band. A developing score of 60 to 74 usually means the templates work, but the crossplane composition is cosmetic, or the operating model is generic without specific times and owners. The abstraction layer is not there yet. A beginning score below 60 means the Backstage portal exists, but it is just a form that creates a repository with no infrastructure wiring behind it. The common mistakes are specific. Building a portal that only platform engineers can use is a wrong customer mistake. A crossplane composition that just wraps a Helm chart has no abstraction value. The value is in the contract, not the wrapper. Antipaths that say, "We will get to it," instead of "no," because are not credible. An operating model that promises 24/7 support with a 3-person team is not realistic. Golden paths nobody asked for are waste, and treating the platform as eternal ignores the fact that every path eventually deprecates. The essential reading for this month is Team Topologies by Skelton and Pace. Chapters 5 through 7 cover platform teams in detail, the patterns, the failure modes, and the relationship between platform teams and stream-aligned teams. Backstage and Crossplane both have strong documentation sites. Backstage's software templates reference is comprehensive. Crossplane's documentation covers XRD schema design and composition patch and transform patterns in depth. Effective DevOps by Jennifer Davis and Catherine Daniels has a chapter on platform as a product that covers the cultural patterns for sustaining developer productivity over multi-year horizons. For offline milestones, onboard one real product team to one golden path and measure the time to first deploy. That measurement will tell you more about your platform than any architecture review. Add cost data per application into Backstage. Add a dev sandbox template that auto-destroys after 24 hours. And run a 30-minute monthly platform demo, showing what shipped is the best way to build trust with your customers. The senior track ends here. You have built, secured, and measured distributed platforms. The lead track takes this foundation and asks a different question. How do you align these platforms to business outcomes, manage risk across systems, and drive engineering culture at the organizational level? Platform roadmap work, executive communication, and technical leadership are lead track territory. When you are ready, that is the next step.